Subscribe Dr. Sadik Mathematics channel for getting more online videos.
D square plus 1 of y that is equal to cot x, d square plus a square of y that is equal to secant ax. Now whenever you observe cot x and secant ax, which is suitable method for such type of problems and how to solve such type of differential equations. The problems on method of variation of parameters. What friends? Problems on method of variation of parameters. Let us see the problem. Solve the differential equation d square plus 1 of y that is equal to cot x. See friends, here 17, 15 and 14. So this is very important problem friends. So I observe here cot x. What friends? Cot x. So what is suitable method here? What is suitable method? Method of variation of parameters. Method of variation of parameters. So solution. Which is suitable method here? Method of variation of parameters. So what is complete solution? That is equal to complementary function plus particular integral. Complementary function plus particular integral. So first I want to find complementary function. So the given problem is already in symbolic form friends. So I write here auxiliary equation. What is auxiliary equation? Y coefficient that is equal to 0. So that we get here d square plus 1 that is equal to 0. Simply we get here d that is equal to plus or minus I friends. How we get here d square is equal to, we get plus I square. We get minus 1 means I square. So d is equal to plus or minus I. So what is complementary function? C1 cos, a value is 1. So cos x plus C2 sin x. You have it friends. So we are applying here method of variation of parameters here. So complementary function you compare with C1 y1 plus C2 y2. So what is y1 here? Cos x and y2 sin x. Now you find friends Wronskian of y1 comma y2. So that is equal to determinant of what is y1? Cos x and y2 sin x. Determinant. So y1 dash cos x derivative. Is minus sin x. Derivative of sin x we get cos x. Okay, that is equal to cos x into cos x, cos square x. So minus and minus plus, here we get sin x into sin x, sin square x. So cos square x, sin square x value is 1. So what is Wronskian formula friends? Determinant of y1, y2, y1 dash and y2 dash friends. So in this way we get here Wronskian value is 1. Now we want to find particular integral. So particular integral formula is minus y1 integral of f of x into y2 by w into dx plus y2 integral of f of x y1 by w into dy. Okay, this is particular integral formula friends. So what is y1? y1 is cos x. So we write here that is equal to minus cos x integral of f of x is here cot x friends. Cot x. y2 is sin x by w value is 1 friends. W value is 1. So into dx plus y2 is sin x integral of f of x is cot x, y1 is sin x, y1 is cos x. into d, sorry, this one also dx friends, dx. So that is equal to minus cos x, integral of this cot x can be written as cos x by sin x into dx. Sorry, we have sin x here also. Sin x dx plus sin x into integral of this cot x again can be written as cos x by sin x into cos x dx. That is equal to minus cos x, this sin x cancel, sin x cancel, integral of cos x is simply sin x plus sin x into integral of this can be cos square x. So cos square x means we have formula cos square x, that is equal to 1 minus sin square x. So it can be written as 1 minus sin square x by sin x into dx. Next line, minus cos x sin x plus sin x integral of, you separate the terms here friends. 1 by sin x means cosecant x, so cosecant x minus sin square x by sin x, so we get a sin x into dx, sin x into dx. So that is equal to minus cos x sin x plus sin x bracket integral of cosecant x is log of cosecant x minus, come on tell me, cot x minus integral of sin x friends, so minus cos x, so minus into minus plus, so plus cos x, that is equal to minus cos x sin x multiplied sin x friends, so sin x log of cosecant x minus cot x in sin x into cos x, so sin x cos x, so plus sin x cos x. If you observe, we have minus cos x sin x here, so here plus sin x cos x cancel friends. So finally we get particular integral sin x log of cosecant x log of cosecant x minus cot x. This is the particular integral friends, So what is complete solution? Y, that is equal to c1 cos x plus c2 sin x. This is complementary function. So particular integral is plus sin x log of cosecant x minus cot x, This is the required solution friends. This is the required solution. Okay, once again friends, this is a very important problem friends, d square plus 1 of y, that is equal cot x. So method of variation of parameters, so complete solution, that is equal to complementary function plus particular integral. We simply write here, okay, auxiliary equation y coefficient that is equal to 0, we get plus or minus I, we get c1 cos x plus c2 sin x. So we are applying method of variation of parameters here. So complementary function can be written as c1 y1 plus c2 y. Compare these two, we get y1 and y2. Okay, and then you find the Wronskian of y1 and y2. Okay, we get this value is 1. We write the formula, substitute minus y1 and y2 f of x w. Here also same. Then we get sin x log of cosecant x minus cot x. We add them, we get the required solution of given problem. If you have any doubt or you want any problem, please comment in the comment box. Hope you understand. Thank you for watching this video. Jai Hind.